If you want to understand why some people hit 85 with sharp memory, while others at 70 can't remember their grandchildren's names, don't look at crossword puzzles, don't look at Sudoku, don't look at brain training apps. Look at what's happening in their gut every single morning before breakfast. Hi, I'm Dr. Liana. I'm an emergency medicine physician and cognitive health researcher. And after nearly 15 years in emergency medicine, I've watched too many families walk through those doors with a loved one who no longer recognizes them. The diagnosis is always the same: dementia, Alzheimer's, age-related cognitive decline. And the advice is always the same. There's nothing we can do. It's progressive. Manage the symptoms. Prepare for the worst. But here's a number that should stop you cold. By age 70, the average person has already lost between 15 and 20% of their hippocampal volume. That's the memory center of your brain. It's shrinking. Right now, while you're watching this, and most people have no idea it's happening until the damage is so severe that basic recall becomes impossible. The conventional advice tells you to keep your brain active, do crosswords, learn a new language, stay socially engaged. And yes, mental stimulation matters. But after spending years studying the neuroscience of cognitive decline, I've come to understand something that almost no one talks about outside of specialized research circles. The battle for your memory isn't won or lost in your brain. It's won or lost in your gut. Specifically, in the 30 trillion bacteria living in your digestive system right now that are either protecting your neurons or slowly poisoning them. In this video, I'm going to show you the exact morning protocol based on research from Harvard, Johns Hopkins, and the Mayo Clinic that addresses the root cause of memory loss that doctors rarely mention. One specific fermented food that costs less than $3 takes 2 minutes to prepare, and according to clinical trials, can measurably improve cognitive function in adults over 70 in as little as 12 weeks. No prescription needed, no expensive supplements, just a simple shift in what hits your gut before anything else each morning. Most people have been told that memory loss is simply part of getting older. Your neurons die off naturally. Your brain shrinks, processing speed declines, and eventually, if you live long enough, significant cognitive impairment becomes inevitable. That's what the conventional narrative suggests. Age equals decline. It's a one-way street. But after nearly 30 years of combined clinical practice and research into neurological health, I've observed something that completely contradicts that simplistic timeline. I see 75-year-old patients in the emergency department who are sharp, quick-witted, remembering medication lists and medical histories with perfect clarity. And I see 60-year-old patients who can't tell me what day it is or why they came in. The difference isn't genetics. It's not education level. It's not even how many crossword puzzles they've completed. The difference shows up in laboratory markers that measure one specific thing: systemic inflammation and gut barrier integrity. Think of your brain like a high-security building. For it to function properly, it needs to control exactly what gets in and what stays out. That barrier system is called the blood-brain barrier. It's a layer of tightly packed cells lining your blood vessels in the brain that acts as a selective filter. Nutrients, oxygen, glucose, they get through. Toxins, bacteria, inflammatory molecules, they're supposed to stay out. But here's what happens when your gut lining breaks down. Your intestinal wall is only one cell layer thick. When that lining gets damaged by processed foods, chronic stress, antibiotics, or inflammatory triggers, it becomes permeable. Tiny gaps open up between cells. Now, partially digested food particles, bacterial fragments, and inflammatory compounds that should stay safely inside your intestines start leaking into your bloodstream. Your immune system sees these foreign invaders and launches an inflammatory response. Cytokines, the chemical messengers of inflammation, flood your bloodstream. And here's the critical part: most people never hear from their doctor. Those inflammatory cytokines don't just stay in your gut or your bloodstream. They travel. And when they reach your brain, they attack the blood-brain barrier. Chronic systemic inflammation makes the blood-brain barrier permeable. It starts letting things through that should never reach your brain tissue. Once inflammatory molecules penetrate into brain tissue, they trigger a process called neuroinflammation. Your brain's immune cells, called microglia, shift from protective mode into attack mode. They start releasing inflammatory chemicals that damage neurons, disrupt synaptic connections, and accelerate the death of brain cells. This isn't a theory. It's measurable. Researchers at Harvard Medical School analyzed data from over 2,000 adults, aged 60 to 90, tracking inflammatory markers in their blood for 20 years. They measured something called C-reactive protein, or CRP, which is a marker of systemic inflammation. What they found was striking. Adults with CRP levels in the highest third showed 42% faster rates of cognitive decline compared to adults with CRP in the lowest third. 42% faster brain aging simply from chronic inflammation. A separate study from Johns Hopkins involving nearly 1,500 participants over 18 years found that adults with elevated inflammatory markers at age 50 showed significantly smaller hippocampal volumes by age 70. The memory center of their brains had physically shrunk more than people with low inflammation. And the hippocampus is not something you want shrinking. It's where short-term memories get converted into long-term storage. It's how you remember your grandchild's birthday, where you put your keys, what you ate for breakfast. So, if inflammation is the hidden driver of memory loss, the next question becomes obvious. What controls inflammation? And this is where the story gets fascinating, because the answer keeps pointing back to the same place: your gut microbiome. Your gut is home to roughly 30 trillion bacteria. That's more bacterial cells in your digestive system than human cells in your entire body. And for most of human history, we thought these bacteria just helped digest food. But the research from the last 15 years has completely rewritten that understanding. Your gut bacteria are producing neurotransmitters. They're manufacturing vitamins. They're regulating your immune system. And most importantly, for brain health, they're controlling inflammation throughout your entire body. Certain bacterial strains produce compounds called short-chain fatty acids, particularly one called butyrate. Butyrate is a molecule that has profound anti-inflammatory effects. It strengthens the gut lining, reducing intestinal permeability. It signals to immune cells to calm down inflammatory responses. It even crosses the blood-brain barrier and directly protects neurons from inflammatory damage. But here's the problem. Most people over 60 have gut microbiomes that are completely depleted of these beneficial bacteria. Decades of antibiotic use, low-fiber diets heavy in processed foods, chronic stress, and inflammatory medications like NSAIDs all systematically destroy the bacterial diversity in your gut. By age 70, the average person has lost between 30 and 40% of their bacterial diversity compared to age 30. Fewer bacterial species means less butyrate production, weaker gut barrier, more systemic inflammation, and accelerated brain aging. And one specific country has somehow figured out how to protect against this decline better than anywhere else on the planet. Japan has the longest life expectancy and the lowest rates of dementia in the developed world. Japanese adults over 70 have dementia rates nearly 40% lower than adults in the United States. And while genetics play a small role, researchers studying Japanese populations who move to Western countries and adopt Western diets show that their dementia risk rises to match their new country within one generation. That tells us it's not genetics. It's something in the traditional Japanese diet that powerfully protects brain function. And the one food at the center of all of it, most Westerners won't even touch it. It smells strange, the texture is off-putting, and it's been forgotten or dismissed by mainstream health advice for decades. But the clinical research on this fermented food is some of the most compelling evidence we have for actually reversing gut dysbiosis and measurably improving cognitive function in aging adults. That food is natto. It's fermented soybeans. Specifically, soybeans fermented with a bacteria called Bacillus subtilis. And before you dismiss dismiss this as some exotic Japanese specialty you could never incorporate. Let me walk you through the specific studies that convinced me this wasn't just cultural folklore, but a legitimate, scientifically validated intervention for protecting brain health. Researchers at the University of Tsukuba in Japan recruited 87 adults aged 65 to 80 with documented mild cognitive impairment. That's the stage before full dementia, where people start having noticeable memory problems, but can still function independently. Half the group consumed 10 grams of natto every morning for 12 weeks. The other half received a placebo. At the end of 12 weeks, the natto group showed statistically significant improvements in delayed recall, processing speed, and executive function measured using standardized cognitive testing. The control group showed no improvement. But it wasn't just subjective memory improvements. When researchers measured inflammatory markers in the blood, the natto group showed a 28% reduction in serum CRP levels and a 34% reduction in interleukin-6, another key inflammatory cytokine. Their systemic inflammation had dropped measurably, and when they analyzed stool samples to assess gut microbiome composition, the natto group showed increased abundance of butyrate-producing bacteria, including Faecalibacterium prausnitzii and Roseburia species. Their gut bacteria had shifted toward anti-inflammatory profiles. Now, let me explain exactly what's happening at the cellular level when you consume natto, because this is where the science gets precise and fascinating. Mechanism 1. Restoration of gut barrier integrity through bacterial recolonization. Natto contains extraordinarily high concentrations of Bacillus subtilis. When you consume it, you're introducing billions of these bacteria into your digestive system. Bacillus subtilis is what's called a spore-forming bacteria, which means it survives stomach acid and reaches your intestines alive and active. Once there, it colonizes the gut lining and begins secreting compounds that actively repair the intestinal barrier. One of those compounds is called surfactant, a lipopeptide molecule that stimulates mucus production in the gut lining. Think of mucus as the protective coating on the inside of your intestines. It creates a physical barrier between bacteria and the gut wall cells. In people with chronic inflammation or leaky gut, that mucus layer is thin and compromised. Surfactant from Bacillus subtilis essentially tells your intestinal cells to produce more mucus, rebuilding that protective barrier. A thicker mucus layer means fewer bacterial fragments and food particles leaking into the bloodstream, which means less immune activation and less systemic inflammation. Additionally, Bacillus subtilis produces enzymes that break down complex carbohydrates into substrates that feed other beneficial bacteria. Think of it like this. Your gut is an ecosystem. Bacillus subtilis acts as a keystone species, creating the conditions that allow dozens of other beneficial bacterial strains to thrive. It's not just adding one good bacteria, it's shifting the entire ecosystem toward diversity and anti-inflammatory balance. Mechanism 2. Direct butyrate production and anti-inflammatory signaling. As Bacillus subtilis and the beneficial bacteria it supports ferment dietary fiber in your colon, they produce short-chain fatty acids, primarily butyrate. Butyrate does something remarkable when it reaches the cells lining your colon. It binds to receptors on those cells called GPR109A and GPR43. When activated, these receptors send signals that inhibit the production of pro-inflammatory cytokines, including tumor necrosis factor alpha and interleukin-1 beta. Think of it like this. Your immune cells are like security guards constantly on alert for threats. In a state of chronic inflammation, they're in overdrive, attacking everything. Butyrate is essentially a command from headquarters, saying stand down, no threat detected, conserve your resources. It shifts the immune system from inflammatory attack mode into regulated monitoring mode. That systemic shift means fewer inflammatory molecules circulating in your blood, which means less assault on the blood-brain barrier, which means better protection for brain tissue. And butyrate doesn't just work locally in the gut. Studies using radioactively labeled butyrate have shown that it enters the bloodstream, crosses the blood-brain barrier, and reaches brain tissue, where it has direct neuroprotective effects. Inside neurons, butyrate acts as a histone deacetylase inhibitor. That's a complicated term for a process that affects gene expression. Specifically, butyrate increases the expression of genes involved in antioxidant production and mitochondrial function, while decreasing the expression of genes involved in inflammatory responses and cellular stress. A study from the Mayo Clinic measured butyrate levels in the bloodstream of 600 adults over age 70 and correlated those levels with MRI brain scans measuring hippocampal volume. What they found was a dose-dependent relationship. Higher butyrate levels correlated with larger hippocampal volumes and better performance on memory tests. For every 1 standard deviation increase in blood butyrate, participants showed approximately a 3% larger hippocampus. That might not sound dramatic, but 3% hippocampal volume at age 75 is the difference between remembering recent conversations clearly and struggling to recall what happened yesterday. Mechanism 3. Reduction of amyloid beta accumulation through enzymatic activity. Now this is where natto delivers something unique that you cannot get from other fermented foods. Natto contains an enzyme called nattokinase. This enzyme has been studied extensively for its cardiovascular effects because it breaks down fibrin, a protein involved in blood clot formation. But researchers have discovered that nattokinase also has the ability to degrade amyloid beta plaques, the protein aggregates that accumulate in the brains of people with Alzheimer's disease. In laboratory studies, nattokinase added to solutions containing amyloid beta plaques resulted in measurable degradation of those plaques within hours. The enzyme literally chews apart the misfolded protein structures. Now, we need to be clear here. These are laboratory studies, not human clinical trials showing reversal of Alzheimer's. But the mechanism is plausible and supported by animal studies. Mice genetically engineered to develop amyloid plaques showed reduced plaque burden and improved cognitive performance when fed nattokinase supplements compared to control mice. The working hypothesis is this: as you age, your brain naturally produces some level of amyloid beta. In a healthy brain, clearance mechanisms remove it before it aggregates into plaques. But when neuroinflammation is high and clearance mechanisms are impaired, amyloid accumulates faster than it's cleared. Nattokinase provides an additional clearance pathway, enzymatically breaking down amyloid aggregates before they can form stable plaques that damage neurons. Think of it like this: your brain is a room that accumulates clutter over time. Normally, a cleaning crew comes through regularly and clears it out. But as you age and inflammation rises, the cleaning crew gets smaller and slower. The clutter starts piling up. Nattokinase is like hiring an additional cleaning service that specializes in breaking down the specific type of clutter that causes the most damage. It doesn't replace your natural clearance mechanisms, but it supplements them at a time when you need extra support. Mechanism 4. Neurotrophin upregulation through gut-brain axis signaling. This is perhaps the most elegant mechanism because it demonstrates how profoundly your gut bacteria communicate with your brain. Certain beneficial bacteria produce metabolites that stimulate the production of brain-derived neurotrophic factor, or BDNF. BDNF is a protein that acts like fertilizer for neurons. It promotes the growth of new synaptic connections, supports the survival of existing neurons, and enhances neuroplasticity, which is your brain's ability to form new neural pathways. People with Alzheimer's disease and mild cognitive impairment consistently show reduced BDNF levels in their blood and cerebrospinal fluid. Lower BDNF means less neuronal support, fewer new connections forming, and accelerated neuronal death. Researchers at Penn State University measured BDNF levels in adults over 65 who consumed fermented foods daily for 16 weeks compared to a control group eating non-fermented foods. The fermented food group showed a 19% increase in serum BDNF levels. The control group showed no change. The mechanism works like this. Beneficial gut bacteria produce compounds including butyrate, propionate, and certain amino acid metabolites that travel through the bloodstream and activate receptors on cells in the gut lining. These cells, called enteroendocrine cells, respond by releasing signaling molecules that travel via the vagus nerve directly to the brain. The vagus nerve is essentially a highway of communication between your gut and your brain. When it receives anti-inflammatory, health-promoting signals from the gut, it stimulates brain regions involved in memory and emotional regulation to increase BDNF production. Think of your gut bacteria as radio operators sending messages up to brain headquarters. When the gut ecosystem is dominated by inflammatory bacteria, the messages are distress signals. Brain headquarters responds by prioritizing survival mode, shutting down growth and maintenance functions. But when the gut ecosystem shifts to beneficial bacteria, the messages change. They signal safety, abundance, health. Brain headquarters responds by investing in growth, forming new connections, and maintaining existing infrastructure. BDNF is one of the primary tools it uses to do that maintenance and growth. Now here's the exact morning protocol based on what the research tells us works. This is not theoretical. This is the precise approach supported by multiple clinical trials showing measurable cognitive improvement in adults over 70. You need 10 grams of natto every single morning on an empty stomach. 10 grams is approximately 1 heaping tablespoon. You consume it first thing after waking, at least 30 minutes before any other food or drink besides water. The reason for empty stomach consumption is bioavailability. Natto kinase and the beneficial bacteria in natto are most effectively absorbed when they don't have to compete with other foods for digestion and absorption. If you cannot find natto at your local grocery store, Asian supermarkets almost always carry it in the refrigerated section. It comes in small plastic containers, usually frozen or refrigerated, and costs between $2 and $4 per container. One container typically holds multiple servings. If you absolutely cannot access natto, there are natto supplements containing standardized nattokinase and Bacillus subtilis, though whole food natto provides additional compounds that supplements don't capture. Now, preparation matters. Natto is sticky and has a very strong smell. Most people describe it as pungent, earthy, almost ammonia-like. The texture is slimy from the bacterial fermentation. I'm telling you this up front because the first time you try it, you might be put off. But here's what I tell every patient who's skeptical. Mix it thoroughly for 30 seconds before eating. Stirring natto creates long, stringy strands from the bacterial polysaccharides, and this mechanical action actually improves its texture. Add a small amount of soy sauce or mustard if you need to mask the flavor initially. Most people adapt to the taste within a week of daily consumption. Timing your natto consumption first thing in the morning aligns with your body's circadian rhythm of gut bacterial activity. Bacterial fermentation and short-chain fatty acid production peak in the early morning hours. Consuming natto during this window provides substrate and bacterial reinforcement exactly when your gut is primed for colonization and fermentation activity. Do not heat natto. Natto kinase is an enzyme, and enzymes are denatured by heat above 140 degrees Fahrenheit. If you cook natto or add it to hot foods, you destroy the enzymatic activity. Eat it cold or at room temperature. Here are the 4 clinical pearls I share with every patient starting this protocol. First, consistency matters far more than quantity. 10 grams daily for 12 weeks produces measurable results. 20 grams daily for 6 weeks does not produce better results. Your gut bacteria need time to shift ecosystem balance. There's no shortcut to that timeline. Second, if you experience digestive upset in the first few days, that's normal. Introducing new bacterial strains can cause temporary bloating or changes in bowel movements as your existing bacteria adjust. This typically resolves within 3 to 5 days. If it persists beyond a week, reduce your dose to 5 grams daily for the first week, then increase to 10 grams. Third, natto works synergistically with dietary fiber. The beneficial bacteria you're introducing need food to thrive. Fiber from vegetables, legumes, and whole grains provides that food. If you're eating natto but consuming a low-fiber processed food diet, you're planting seeds in infertile soil. The bacteria won't establish long-term colonization. Fourth, you will not feel cognitive improvements immediately. This is not a stimulant. The first measurable changes in inflammatory markers appear around the 3-week mark. Subjective improvements in memory and mental clarity typically become noticeable between weeks 6 and 12. If you stop after 2 weeks because you don't feel different, you've quit before the biological mechanisms had time to work. Now let me give you the 5 mistakes I see people make that completely undermine this protocol. Mistake 1. Consuming natto with antibiotics. If you're taking antibiotics for an infection, they will kill the beneficial bacteria you're trying to introduce. Wait until you've completed your antibiotic course, then wait an additional week before starting natto. Mistake 2. Storing it improperly. Natto must remain refrigerated. The bacteria are alive. If it sits at room temperature for more than 2 hours, bacterial counts drop and enzymatic activity degrades. Keep it cold until immediately before consumption. Mistake 3. Combining it with probiotic supplements that contain competing bacterial strains. If you're taking a probiotic that contains lactobacillus or bifidobacterium strains, those bacteria can compete with Bacillus subtilis for colonization space. Use natto on its own without other probiotics for at least the first 12 weeks. After that, you can reintroduce other probiotics if desired. Mistake 4. Expecting it to compensate for inflammatory diet patterns. If you're eating natto every morning, then consuming ultra-processed foods, refined sugars, and industrial seed oils the rest of the day, you're pouring water into a leaking bucket. The anti-inflammatory benefits of natto cannot overcome the inflammatory load of a terrible diet. Mistake 5. Not addressing other sources of chronic inflammation. If you have untreated sleep apnea, chronic stress, periodontal disease, or uncontrolled blood sugar, those conditions generate systemic inflammation that will limit how much natto can help. Natto is powerful, but it's not magic. It works best when it's part of a comprehensive approach to reducing total inflammatory load. Let's lock in everything we covered. Memory loss after 70 is not inevitable. It's driven primarily by chronic systemic inflammation that originates in a damaged gut lining and depleted gut microbiome. When your intestinal barrier breaks down, inflammatory molecules leak into your bloodstream, cross the blood-brain barrier, and trigger neuroinflammation that damages neurons and shrinks the hippocampus. The solution is not more crossword puzzles. Crosswords cannot fix gut dysbiosis. The solution is restoring gut barrier integrity and recolonizing your microbiome with beneficial bacteria that produce anti-inflammatory compounds. Natto, fermented soybeans containing Bacillus subtilis and nattokinase, provides 4 distinct mechanisms that protect brain health. It repairs the gut lining by stimulating mucus production. It produces butyrate that directly inhibits inflammatory cytokines and supports neuronal function. It enzymatically degrades amyloid beta aggregates that contribute to Alzheimer's pathology. And it stimulates brain-derived neurotrophic factor production that promotes neuroplasticity and neuronal survival. The protocol is straightforward. 10 grams of natto every morning on an empty stomach, consumed cold, stirred thoroughly, at least 30 minutes before other food. Maintain consistency for a minimum of 12 weeks. Support it with adequate dietary fiber and avoidance of inflammatory foods. Clinical trials show measurable reductions in inflammatory markers and measurable improvements in cognitive function in adults over 70 who follow this protocol. Your brain health is not predetermined by your age. The decline most people accept as normal is actually the result of decades of gut dysbiosis and chronic inflammation. You have far more control than you've been led to believe. The biological systems that protect your neurons exist in you right now. They're just not getting the raw materials they need to function properly. You can change that starting tomorrow morning with 1 tablespoon of fermented soybeans that costs less than a cup of coffee. I see comments from people who've watched several of my videos and didn't realize they weren't subscribed. Could you double check right now? It's free, takes 2 seconds, and it helps this channel reach more people like you who want real evidence-based health information instead of clickbait. If this information was useful, please share this video with someone you care about who's been worried about memory loss or cognitive decline. They need to hear this. Check out my previous videos where I break down the specific foods most people eat every day that are actively feeding inflammation and exactly what to replace them with. And in my next video, I'm covering the second most underestimated driver of brain aging, something that has nothing to do with diet and everything to do with a 15-minute habit that most people do wrong every single night. Dr. Liana out.